All right, so in this session, we will see what is the permutation and combination. All right, so first of all, we will see what is a permutation. It is a very small topic. So in a permutation, it's all about arranging the objects, right? Permutation means to arrange object in some sort of order, right? Like let's say if you are arranging alphabet, so you will be arranging alphabet in the alphabetical order, right? So permutation is all about arranging the things or the objects in some sort of order. So the main thing is the order matters, right? Order always matters. It's about arranging all the objects in order. Let's say you have three colored balls, red, yellow, and blue, right? So you have three colored balls. So what you do is how you can arrange all these colored balls. So let's say you have in a first setting, you can arrange them as the red, yellow, and blue, right? So RYB. So this would be your first arrangement, right? In a second arrangement, what you can do is you can take the red, blue, and yellow. In a third arrangement, what you can do is you can take the yellow first, then red, then blue. So this would be your third arrangement. In a fourth arrangement, what you can do here is that you would take blue first and then red, right? So this would be your fourth arrangement, is that you can take blue first, then red, then yellow, right? And so this would be your fifth arrangement. And again, finally, in your sixth arrangement, what you can do here is that first you take blue, then take your yellow, and then in the last you take red, right? So these all will be your sixth arrangement, right? So in a six ways you can arrange these objects, right? So there are six ways you can arrange all of these objects, right? So I have done this manually, right? So let's say you had 10 balls, then how many ways you can arrange them? Let's say you have 20 balls, how many so if the number of balls or number of objects are increased, then you can't just make each and every arrangement with your hand or manually, right? So it would be difficult. So there should be some sort of formula to solve this. So for the permutation, we have a very simple formula here, and which is called NPR. This NPR is equals to n factorial divided by n minus r factorial, right? So n factorial, n minus r factorial. So what is n here? N is the total number of balls here, right? So how you're gonna do this? And r here is the number of balls that you have to, number of objects that you have to arrange out of these, right? So here what you can do, if I wanted to do here, right, if I wanted to solve this, so if I solve this this question with the help of the given formula, then how we're going to solve this? So we had all of these three balls, so we had like 3 factorial, right? N would be 3, and if I write this, n would be 3, and out of 3, how many balls we are taking for the arrangement? Again 3. So we are taking all of these balls, right, for the arrangement. So again, r would also be 3. So if I put this in this formula, so it will be like 3 minus 2, which is 3 minus 3 here would be like, so in a denominator you would get 0 factorial, and this 3 factorial in numerator will be opened up like this: 3 multiplied by 2 multiplied by 1, right? So in the denominator, 0 factorial, like 0 factorial is always equals to 1. So in a denominator, you will get 1, and in the numerator, you have 3 into 2 into 1, which is 6. So in total, what you have 6 ways, total 6 ways that you can arrange these objects, right? So we got like 6 ways. Here you can see. So we did manually, we did with a formula. I hope you understand how to perform a permutation. Now let's come to the combination, right? So combination is again also easy. But the here is the thing is that order doesn't matter in combination, right? So how you gonna identify whether it is a permutation or a combination problem? So it is quite easy. Whenever there is a concept of arranging the objects in order, then you can just say it is the permutation. But whenever there is a thing that whenever you have to select some object, right, or choose some object, then in that case, and if in that case order is not matter, right? So in that case it is called as combination, right? So it is quite easy to distinguish between the permutation combination. It is based on the order, and always it is going to be choosing or selecting objects in the combination and arranging the objects in the permutation, right? So in a combination, order doesn't matter, and we do not have to arrange those objects, we just have to select those objects, right? So let's say you have three colored ball. Again, I'm taking the same example, red, yellow, blue, and you have to select two balls out of three. You have to select like two balls out of three. So how many combinations can you make? So out of these three, I have to select. Now I can select in any order, order doesn't matter. And if I have to select all of these objects, let's say, so first I select red and let's say yellow. So first I select red and yellow, then I say like I can select red and blue, and then I can select yellow and blue. So there are the three combinations that I can make while selecting these three these balls, right? So red, yellow, red, blue, and yellow, blue, right? So in this way, red, yellow, if you can say, oh, okay, we can also select like this, yellow and red. So these two things are same, right? So these two things in terms of combination are same, are considered as a single entity, right? Similarly, if you say like, oh, why didn't you select like blue and R, right? So if I select blue and R, so these two are considered as a single entity, right? These two are selected as a single entity. These two are selected as a single entity. If I say blue and yellow, then these two are considered as a single entity or a single combination, right? So this is only one combination, this is only one combination, and this is only one combination. So 1 plus 1 is equals to 3. So three combinations that we can make, right, in this thing. So if I just tell you about the formula, is quite easy for the combination here. So it is around NCR is equals to n factorial divided by n minus r factorial. It is similar to the permutation till here, and the simple change is that you put r factorial in a denominator also, right? So your main formula is look like this. So n factorial, n minus r factorial, and r factorial, right? So if I solve this question again with the formula, then how you gonna solve this? So in this way, we have the n is equals to 3. And out of 3, we have to select two balls. So we have to select two balls out of 3. So R will be 2, right? So if I put all of this in our formula here, so we have 3 factorial and we have 3 minus 2 factorial and 2 factorial. So in this case, we have like 3 into 2 into 1 in the numerator. If I open up my 3 factorial, and if I just go with 3 minus 2, this is the 1 factorial. So 1 factorial is eventually 1. And this, if I open up this 2 factorial, so it is like 2 multiplied by 1. So if I cross out this 2 into 2, so I get only 3, right? So 3, so there are 3 possible combinations that I can make out of these things, right? So I proved that with the manually, and I proved that with the combination formula. So I hope you understand this. This is a basic concept and basic difference between the combination and the permutation. So in the permutation, we have the arrangement in order, but in terms of combination, we have to select or choose the objects while the order doesn't matter, right? So I hope you understand this.